All right, we're going to go ahead and get started. And like I told you, there's not a lot to do today. This one example is kind of long because of all the work that you have to do. But other than that, there's not much else left. So it's basically this page and then kind of talking a little bit about some different types of plots. So assessing normality. The normal distributions provide good models for some distributions of real data. While experience can suggest whether or not a normal distribution is a reasonable model, in a particular case, it is risky to assume that a distribution is normal without actually inspecting the data. So the question is, are the data normal? So this is going to take forever, but you need a calculator if you don't have one. If you're sitting in here and you'd rather use one of mine, go grab one of mine. I'll clean them after you leave. If you're at home, get your calculator out. This problem is not hard, it's long, okay? So the first hard part about it, or the first long part about it, is that you have to put all this data into L1. So put them all into L1. So we go to stat and put them in there. So to tell whether it's close to normal, and you can write this down in a minute, keep putting those in and listen while you're typing those in. Are the data close to normal? We're going to find out if it falls. So does it fall close to the 68, 95, 99.7 rule? And those of you at home, I would definitely suggest that you do this, okay? So don't just be sitting there like, oh, Miss Jones, you're making me wait forever. Do it. Because I'm pretty sure there's one like this on your test. I'm almost certain.
Jones, isn't it 2.35 in the last box? Or is it 2.3?
What last spot? What?
Like in the third line where it goes 34, 13 and a half.
What is he talking about?
On the bell curve, the different sections that are each different percentages.
Talking about the data. Tell me again what you said.
Is it 2.35 or 2.3 in
Okay.
like the last?
So what we talked about was if it's.
I was looking for that number in this data. I was like, what in the world is he talking about?
I was doing. I'm a little upset that I'm thinking like you, Haley, but it's okay.
No, it's good.
So we have 1, 2, 3, -1, -2, -3. Now you have your 34 in here and your 13.5 on either side here. This whole set is 2.5. This one section is that 2.35.
Okay, that's what I wanted to know, if it was 3.5 or just 3.
No, I think it's 3.5.
Yeah, that's what I thought it was, but then I wasn't sure. It's
Yeah.
super small, but
Yeah. And usually, like if you're doing multiple choice, they may use the 2.35. That's what I told you. But if you're doing it on your work, I will count the 2.5. All right. Sorry, now y'all gotta wait on me to put this in. Stat, edit. Get this out. 4.1, 4.5, 5. Take a minute and make sure that you put them in correctly while I'm typing them in. And I could get them wrong. There's no telling. Today has been one of those days. Everything has gone wrong. 8, 8.2, 8.4, 8.5, 6, 7, 9, 2, 9, 5, 9, 6, 7. Okay, I think I have them all. 50 data points. Did y'all get 50 data points? Yeah, okay. All right. So then I want to make a box plot so I can see maybe is it normal? What? Okay, if you put on the last one, it should tell you 50. If it says 51, you need to check your data. If it says 49, you need to check your data. You probably missed a repeat. And you don't have to put it, you can put it down in the bottom. You don't have to like insert it in there in the right order. Okay. All right. So how do we make a box plot?
Median and all the quartiles.
Yeah, how do we make it on a calculator though? First thing I do is check my y equals and get that crap out of there that I got because I don't want to screw y'all up. And then do second y equals. And we're going to turn our plot on. And which box plot do we want? The one with the dots. So that'll show my outliers. L1, blah, 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 blah. How do we get it on our screen? Because we can't just graph. It won't just graph it. What do we got to do? How do we graph in stats? What do we got to push? Zoom.
Isn't it Zoom 9?
It sure is. Zoom 9 is Zoom stat. You got to see how 9 is stat. You're going to go to second y equals. Hit enter. And then make sure it's turned on. You have the modified box plot. And then Zoom 9. What do y'all think about this?
Okay, so after you do stat and put it all in, and then can you do it again? I was paying attention, I promise. I just want to make it.
This will be the third time that I've done it, Haley. Second,
Okay, well, I'm watching.
y equals.
Okay.
Hit enter.
Yep.
Make sure you turn it on. Do
Okay.
the box and whisker with the dots,
Okay.
and then Zoom 9.
Okay. Gotcha.
Tell me about this graph. Now it's not the time to be quiet. Y'all are wasting homework time. Is it? They said it was right skewed. Do y'all agree with that, Zoomers?
Yeah.
Yes.
Well, stop agreeing with him.
No, it's
Yeah,
roughly symmetrical.
It is roughly symmetrical because even though it's a little bit to the right, I mean to the left, and I understand y'all saying that, it's fairly center in those whiskers. So the whiskers are not like a big massive difference. So you'll see, especially on the AP exam and stuff like that, you'll see a big difference. It won't be so like it won't be this subtle. It'll be like the boxes all the way to the left or all the way to the right. You'll know if it's right or left skewed. Okay.
Does it need outliers to be skewed?
It does need outliers to be skewed, but with the modified, it will not show, like these don't have any outliers, right? So that tells you right now that it's not skewed because it's not got those outliers. But at the same time, you can have skewed data without showing outliers, if that makes sense. Okay, it just depends on how it is. All right, so the second thing we did was we made a box plot. And you said, and I'm going to write that down, you said looks normal, but a little skewed. Okay. So this is how you tell if you're not sure, is it skewed or is it normal? And I'm telling you again, when they do them on the final exam and stuff like that, it's gonna be so good that you can tell, okay? They don't try to trick you on that part. So the third thing we're gonna do is check the rule. I'm gonna check the rule. So the things that you need to check the rule are you need the mean and the standard deviation. Where can I get the mean and standard deviation? Where can I get the mean and standard deviation? Ooh, we have forgotten a lot, eh? Where does the calculator give us the mean and standard deviation? Uh-huh. Stat, over to calc, and 1 bar stats. L1, that's what we want. And what's our mean?
8.72.
I got 682. Should be 682. You may have a data point that's incorrect, okay? Just watch that.
I also got 7.1 or 8.71.
Then you have a data point. I'm telling you, this is the mean. So if you don't have this, you have a data point incorrect. What's your standard deviation? Those of you that have it correct. It's on the screen.
0.22.
2.22, and I'm going to put 5. So what does our rule say? What does our rule say? Our 68, 95, 99.7 rule. What is the 68? What does it mean? I just drew it for you.
68% of data is within 1 standard deviation.
Right. So if we're checking our 68% part, we're going to do 1 standard deviation above the mean and 1 standard deviation below the mean. I'm going to split this up. We're going to do the less first, okay, the smallest one first. So our mean is 8.682, and we're going to subtract 1 standard deviation. 8.682, and we're going to add 1 standard deviation. We're going to get those 2 values. So we should have 6.457 and 10.907. We're going to do this for the 95 and the 99.7, and then we'll figure out how much data comes in there, okay? We'll figure it all out. So then for 95, it says it's the mean plus or minus 2 standard deviations. So again, I'm going to do the minus first. 8.682 minus 2 times 2.225. 8.682 plus 2.225. The low value is 4.232, and the high value is 13.132. Does everybody understand where those numbers are coming from? Everybody okay? And then 99.7 is the mean plus or minus 3 standard deviations. 8.682 minus 3 times 2.225. And 8.682 plus 3 times 2.225.
Okay, where are you getting the 1, 2, and 3 from?
Right here. 1 standard deviation, 2 standard deviations, and 3 standard deviations.
And it's always going to be like that.
Yes, because if we go back up here, 68% of data is between -1 and 1. So 1 above and 1 below the mean. That's your 60.
Oh, okay.
Then 2 is your 95%. So that's where the 2 is coming from, 2 above and 2 below.
Yeah, I got you now.
Okay. Those values are 2.007 and 15.357. The last step we're going to do is find out how many data sets, how many data points come between that value. Okay. So the fourth step, and you can do this 3 and 4 simultaneously. That's not a big deal. I just separate them. So you're looking for how many values in each range. All right, so your first range was mean plus or minus 1 standard deviation. What are the values in your chart? Let me try to do this. Yep. That are between 6.457 and 10.907. So start looking, 6.4 is not, so your first value is 6.6. 6.7, 6.7. All the way up to 10.9. How many data points is that?
36.
Wouldn't 10.9 be included into that too? Because it's
Yes.
10.907.
Sorry, I just was looking at 10.9. You are correct. Thank you. How many data points is that?
36.
36. And that's out of 50 total. That's all I wrote. 36 out of 50. Which is 72%, which is actually really close to 68. It's not going to be perfect unless it's a perfect normal plot. So we said this one was a little skewed, right? So it's going to be a little bit off. But watch as we get further away. So then do your 2 standard deviations. So that goes all the way down to 4.232 and all the way up to 13.13. So again, 4.2 is the least we can go. So that includes all those, and we go up to 13.13. Be smart about this. Be smart about this. I have not shaded 2 or highlighted 2 of the values. So how many are left? There were 50. I didn't do 2 of them. 48, thank you. So we got 48 out of 50, which is 96%. That's real close to 95, right? Does everybody see that? Now, when we do plus or minus 3 standard deviations, that's up to 15 and down to 2, which makes 50 out of 50 would be included, or 100%, which is also super close to 99.7. So this one is fairly normal. Can you see where you thought that it was skewed? Can you guys see that? So our low values are the ones that are like our mid values or whatever, the ones that are kind of weird. So right there, that box is shifted just a little bit. That's all it is. Okay. I told you this one was a long problem, but it's not hard. And that's pretty much all we're doing. All right, I do want to look at normal probability plots.
How much of a difference would those numbers have to be for it not to be normal?
Huge.
Huge.
Yeah.
Okay.
They're not ever, like I said, they don't try to trick you like that. They don't make it like 68 and 69 is not normal. Y'all understand what I'm saying? They'll make it like the first set is
So
68.
you won't trick us either on our test?
What? What?
So you won't trick us either?
No. They'll be fairly close. If you're looking for 68 and it's like 52, that's a problem. If you're looking for 68 and it's 66, that's not bad.
So typically, if it's bigger than a 10% difference, then that would be not normal,
You know,
right?
y'all getting too technical. I'm telling you, it's gonna be a yes or a no, and you're gonna know.
Well, this is how I am. I would overthink stuff like that, and I would miss that problem because of that.
Don't overthink it. Don't overthink it. Basically, on that problem, they're gonna get. I would say that they would not make you do that work for it not to be normal, if that makes sense. They're just showing how you use that rule. I don't think that that would be anything like, if you want to show normality, that would not be the first thing that I would tell you to go to. The box plot would be. Okay. And you can see it's a little bit skewed, but it's roughly symmetric. Okay. It's always going to be like that. And as we get through this, as we get through more, you will see different ways to assess normality. Okay. So it won't be a big deal. All right. So making a normal probability plot, this is on page 123. And I know that you're probably not going to look at your books, but I didn't really put this in the notes because they don't really test on this. And you'll see that at the bottom. Normal probability plots are not included in the AP topics. However, you can use them on the AP exam just to know that you're looking for an overall pattern. And I'll explain it in just a minute. And it should be linear. Okay, so an overall pattern, it should be linear. We're going back up, but I'm going to explain them to you. And the only reason I need to explain these is because I think you have a question on your homework that deals with these. So here's what you're looking for. And these are on page 123. This one plot is on there. They look like a dot scatter plot. So if you have them and they're lined up and they're going, like, there's tons of dots, y'all. There are tons of them. And they're going in a linear pattern. I'm going to show you one. It's an alternate example. Let me try to get it up there so you can see it. See how this one is all linear? That means it's normal. Everybody got it? That means it's normal. When it has a curve to it, like this one, it's just a little curve, so it's fairly normal, but it does have a little bit of skew. Anywhere you see that curve, if the curve is on the low end, that's going to be the skew that you're going to talk about. And I'll show you, try to show you an example. All right, so then you have guinea pig survival. So that's that next page. Remember, I told you I don't really have anything to tell you. I just want to show you, okay? So if you have to write them down, this is where they're at. So the guinea pig survival, it says determine whether these data are approximately normally distributed. So it gives you this plot over here, and you guys see, see how it's not linear? You good? Where is the curve at? Where's the curve at? Left or right? It's on the left. So this one is the opposite. It is right skewed because the tail would be on the right. Okay, so you have heavy data in the curve. If you need to write that down, write it down. You have heavy data in that curve. So this one would be right skewed. Again, if you look at this plot right here, you can tell it's heavy on this end, and your outliers or your smaller data is on the other end. So your tail would be on the right. So this is just a comparison of like a histogram and a normal probability plot. But again, what you're looking for, my nose is itching, sorry. What you're looking for is that curve, okay? Is everybody good? So if the curve is on the low end, it is right skewed. If it's on the high end, it's left skewed. Okay. Let me see if I can find a left skewed example. Here are your ones for today. I don't see any left skewed in here at all. Here's your problems for today. What would this one be?
Fairly normal.
Yeah, because it's pretty linear, right? So I think this one is your question for your homework. What's this one?
Right skewed.
Right skewed because it's all curved over here. Got it? All right, so that's one of your homework problems. And that's the only thing that we really do. 74. You guys see 74 over there? It's fairly linear right here, but then it has this crazy curve. This curve is on the left, so this one is right skewed. So when you do 74, you should choose right skewed. So I got it. If I find one that's left skewed, I'll show you that too. But I don't see one. All right, so very good. That's pretty much it. So that's what the last of your notes were. So if you need to make extra notes on there, then go ahead and do that. And we're not going to do the technology. Again, the probability props are not on the AP exam, and we are not going to choose to do those. I can promise you that. Okay.